All right, we are live. Good morning, good afternoon, good evening, everyone. My name is Jim. I'm a developer advocate here at Tinybird, live from my basement in Colorado in the US. And I'm joined today by my colleague, April. April, do you want to introduce yourself?
Sure. Thanks, Jim. Hi, I'm April, another developer advocate here. I've been here about 6 weeks, so still learning a lot and excited to be on the stream today so that I can learn from Jim alongside all of you. I'm tuning in today from Pittsburgh, Pennsylvania in the US. So I guess first question for the chat, where are you tuning in from? I wonder who is the furthest away and the closest to us. Maybe there's someone directly in the middle of us, Jim.
Exactly. And yeah, we'll be posting different questions as we go through the material. Just an attempt to keep this a little bit more interactive, and we're always curious about who's viewing and what your story is. And today we're talking about building performant analytics dashboards over Postgres data. So let's kick off. In a little bit, we'll be digging into this dashboard that I put together for today. I often say that April and I are lucky to be advocates for Tinybird's platform because I do really enjoy working with the platform. I'm always amazed by the type of things it brings to the table. The fact that someone like me on my own, I have a passion project around weather data and how you can build things, live systems. And then I'm going to be showing later, I'll be showing a second version of the dashboard. And in this one, we'll be doing some comparisons with latencies between pulling data from a Postgres database and also pulling data from a Tinybird workspace. So one big reason we're talking about Postgres, this is something a colleague referred me to just recently. It's the Stack Overflow survey for 2024. And surprising or not, Postgres is the top. And this is even looking at professional developers. That Postgres was the number one ranking. You'll see a lot of familiar names in this list. So
I wonder how many people in the audience have used Postgres, right? Because if it's 52%, surely there has to be at least one person. I'll post this next question. Who's using Postgres for their production products? And we'll see if we get any love there in the chat. But it is pretty amazing, right? When there's so many different tools out there for something to be that ubiquitous, right? More than half the time using it. So being able to use Postgres together with Tinybird is just that much better. So
yeah. And I have a lot of fondness for Postgres. Going way back, I cut my teeth on MySQL. We use that for a lot of production systems a couple chapters ago for me. But more recently, I've used Postgres myself, put together one semi-production product in my former life. But when I do start projects, I often would go to Postgres as a place to start. It has tons of community support. It can just serve database needs across many different use cases. And I will say, it seems like Postgres and other relational databases sometimes get a bad rap about, it works up to a few million rows, but I think that's pretty much old news. I think Postgres is a very modern database these days. And certainly with the hardware that's available today, you can manage, sometimes you hear, you can only manage up to a few million rows. And I don't think that's the case anymore. I mean, if you do some searching, there's examples out there of people managing billions of rows with Postgres. So, and related to that, and one reason we're here is I wanted to just show this. There's a blog post a colleague turned me on to about Figma and how they were using Postgres, but they were getting to a point where the performance, they were just outgrowing it, they felt. So they did a huge re-engineering of their platform in terms of how they use Postgres. Namely, they're doing all kinds of horizontal sharding and replicas. But one interesting thing about, and you can go read this blog post, it's quite detailed and it's quite a journey they took. But bottom line, this describes a project that took 9 months, and they used 20 database engineers to kind of make it happen. And, of course, they were basically updating their engines while they were flying the plane. So, of course, they did it very methodically and made it so their production system didn't notice. But
Yeah, I think that's one of the things that's the power of tools like Tinybird is it enables like even you, Jim, right? Single person to build out this demo and everything together, but Tinybird is still allows you to be collaborative, right? You can have a shared workspace, work together. You can, use Git with Tinybird, like all of those normal good things you would want. But Tinybird handles a lot of that stuff that team of 20 would have had to do just to get things going there. And I know you were mentioning size. I'm curious, anyone in the chat, how big are your largest tables? How many millions of rows for this demo today, Jim? How many rows do you have?
I'm working with a database of weather reports. I think there's around 10 million.
Wow. Yeah. So that's pretty good. But yeah, like you said, we can get up to billions here. But
yeah, for sure.
Let's keep going. What else are we covering here today?
Yeah, just to run through some of the topics we'll touch upon today. One, of course, is building Postgres-driven dashboards. I'm going to be using Retool, and I'll explain why I picked Retool in a minute. But we'll go through a list of tips for optimizing your Postgres performance. Then I'm going to do some testing. We're going to test Postgres with a lot of highly concurrent requests. I'll be running a script in the background that'll be mimicking a lot of database connection requests coming in. And then we're going to do some comparisons with performance in that frame with Tinybird. And then we'll talk about methods for building highly performant dashboards over this Postgres data.
Sounds good.
Let's do it. So before I jump in, though, I do want to spend a few minutes just, giving some context. I assume there's going to be folks in the audience who may not be that familiar with Tinybird, so I'll just spend a minute or two talking about what it is. One, it has an OLAP database as its data layer. We are using ClickHouse under the hood. We've abstracted that away. You can think of Tinybird in some sense as a managed ClickHouse. ClickHouse is a very performant database built for receiving volumes and volumes of real-time event data. You can work with billions and billions of rows with very efficient queries. Tinybird is a platform for unifying data sources. This is a very common use case with our customers where they have maybe a live streaming data source. Maybe they have several streams, but they probably also have dimensional data living somewhere else, maybe in Postgres, maybe in Snowflake, BigQuery, you name it. You can pull it into Tinybird.
Yeah, I think that's part of the power too, right? Because realistically, in an IT landscape, you have data in multiple places, right? Like that's part of why all these different data tools have come out. So the fact that in Tinybird, there's so many different ways that you can bring data in and then easily work with it together, expose it as APIs, it's very helpful. So
yeah. And we have a whole suite of what we call native connectors, Snowflake and BigQuery and S3, others. But then if your data lives in some other place that we don't have a integrated connector for, we also have this thing called the Events API where you can basically stream data to our platform. And once all that data is in our platform, Tinybird, of course, is a data analysis platform. You can use SQL, you can merge, filter, aggregate this data, do all kinds of analysis. And then when you're ready, you can, with the click of a button, you can publish an API. You can build data products using Tinybird. So that is what Tinybird is.
Yeah. How much experience do people in the audience have with Tinybird? As everyone can tell, I'm having a lot of fun with these banners, trying to ask some questions to the audience here. So feel free to leave a comment in the chat and let us know, are you brand new? Do you have a lot of experience, between me and Jim? It's a big gap, but I'm ramping up quickly here. So yeah.
Nice. So let's talk a little bit more about Postgres. In my case, I landed on a Postgres host called Supabase. They have a lot of different features, but the one I gravitated for this event was their Postgres hosting. So let's just take a quick look at what we've built there. I have this table called weather reports. This is the one, I guess it says it has 8.8 million records in this. This is 10-minute data that actually I've been collecting for the last 15 months. It's 10-minute weather reports from 175 cities from across the United States. And I also have a second table. This is, so you can think of this weather reports as the live event stream. Data is showing up here every few minutes. Then I also have a location metadata table. This is a dimensional table. It doesn't really change much. And later in this session, we'll be importing these into Tinybird so we can work with them there and then publish APIs. And, you know, that's one amazing thing about Postgres. There is just so many different SaaS companies out there that support that database, be it in terms of hosting. And I'm curious also, everyone out there, who's hosting their own Postgres in-house? Because I imagine that there's going to be more people hosting it elsewhere. Obviously, that helps, especially smaller teams, just with setting up the database, with scaling it, with running replications, what have you. And I was super impressed with Supabase. It didn't take me very long to pull this 10 million reports into it. It has a very nice user interface. There's also a full suite of APIs to pull data in. In my case, I used a feature in Tinybird. We have a S3 sync, so I was able to take my 10 million reports and export them as S3 CSV files, and then actually using the Supabase interface, I was able to chunk that data into smaller files and pull them into Supabase. So let's get into the dashboard. As I mentioned, I built this dashboard with Retool. If you're not familiar with Retool, it's sort of a no-code type website development tool, which is perfect for me. I think of myself more as a back-end Python developer. I don't have a lot of JavaScript experience. I can read it, I can update code, but it would take me a while to build what I built with Retool. So what we have here is an interface showing those 10 million different reports. What you're seeing is totally driven by Postgres, the table I just showed you. With this interface, you can come in and pick, again, there's 175 different cities in here. Let's go up to Alaska, see what's going on up there. Of course, it has date pickers where you can change. Here, I'm going to change just to look at the last few days of data. So what you see here is, the different types of sensors I'm collecting: temperature, wind speed, humidity, what have you. Over here is a table view of that same data. If you scroll over, you can see the different types of sensors for each data point. This table, this chart is a little bit different. This is doing some aggregates. It's doing averages and mins and maxes of temperature. That one's a little bit more involved. And if you're maybe you're not a full-on front-end developer. If you are not, I totally recommend Retool as a way to at least prototype. I'll show you how I set this up. Let's see here. Like, here is an example of, well, let me back up. Say you're going to add one of your tables. You go to resource query. You can see here, I can zoom in a little bit. You can see the different choices here. Of course, I picked Postgres, but they also have built-in integrations for Mongo and MySQL, what have you. You select this. This is where you can set up your connection to your database. The main points here are your host. Here, I'll show you my real one. So if I come in here, if I want to look at that, if I come in here, I want to edit that. So here, for example, I can show you, this is my host of my database. You can see it's out at supabase.com. Put in your port, you put in your connection details, what have you. And then once you're there, here's a query, for example. I'm selecting from that table weather reports. And this is the cool thing where I have these widgets. I have a select city widget. I have a start time and an end time, and there you can pull these values dynamically into your query. So if I change this, the data gets passed in accordingly. I'll show you the other one as well. This one's a little bit more involved just because it's doing some aggregates. Typically these are the queries that'll take a little bit longer to complete. And I will say that's one thing that Tinybird really shines at, is building these types of aggregate queries. What else to show? When I show you the next version of the dashboard, I'll show you how you also can connect in a Tinybird endpoint. But I want to show, let's show this live again. And here, again, I can click around, pull in different data. You can see it's pretty performant, but if I go back, say I want to pull in 6 weeks of data, it does take a bit of time to go get that data. There it took maybe 3-4 seconds. So when you're building a user-facing dashboard or any type of web app, that's something that, of course, you're going to be focused on. How big is that latency? So what I've found is in this implementation, I can go back far enough and this really starts to get slow. Still works, but you wouldn't want that type of performance on a user-facing website.
Yeah, something I always kind of talk about is the biggest consumer like SaaS things, right? Like social media and stuff. They have huge teams that are like trying to make it as easy and performant as possible for the average person. So then when they go to work and are using some SaaS product, or if you're trying to build something and there's more latency, it's like, why is this so slow? Because everyone is just like used to these very common products being very performant. And I know for me, a few seconds and I'm like, oh my gosh, come on.
So, obviously if you're hosting a Postgres database in-house, I hope you have a DBA, someone who's well-versed in all the nuances of these databases, who are going to be experts on how to get as much performance as you can out of your Postgres instance. Obviously, that's a huge reason people will host it elsewhere, where you have an entire company who's dedicated to abstracting all of those issues away from you. Away. So, as you grow, typically these type of services will auto scale for you. And speaking of that, let's go through some of the ways you can tune and improve your Postgres performance. I kind of have a feeling I'm preaching to the choir here. If any of you out there are now using Postgres, or for that matter, any other database, you're going to be very familiar with these. But let's review these.
While you go into that, Jim, I'm just curious for the audience. Have you ever encountered any performance issues with any of your Postgres-backed dashboards? So while giving the chat a chance to maybe answer that question, let's hear some of these tuning tips.
Okay, sounds good. One is very logical. Just think carefully about what data you're pulling. I'll click on this. We have a very popular post about what are the best practices for building SQL, fast SQL. And, one is, of course, be selective in the data you're pulling. You can imagine a database with, 100 different attributes. Maybe you don't need all of them for a query. Maybe you only need 5. Well, just doing simple things like that can help you really make things more efficient. Another one is optimizing queries. These are very interrelated, these two items, but obviously you can use tools like Explain. Postgres has some other tools that help you analyze your queries. A lot of these SaaS companies will actually help you with a human expert optimize your stuff. That's one thing I love about Tinybird, is as we work with our customers and they build more and more advanced queries, we will spend time with them and help them fine tune and optimize these queries to make them faster. And that's a key part of all these latencies you're seeing, is how much time does that query take to go get the data. Indexing, obviously, this is key. In fact, when you set up a database in Supabase, they won't let you walk away without an index. You have to have an index. And part of this is thinking about how is your data going to be queried. In my case, all these queries, as you can see by the interface, are driven by the site name, the city name, and the start and end time. So I have indexes around those fields. So when I go in for a long query, it's optimized at that level to pull back that data quickly. Another one is partitioning. Certainly as your tables grow into the millions and certainly into the billions, you got to start thinking about partitioning your data, actually splitting your table into chunks. You might organize your data by month, you might do it by year, but that's a key thing to consider as well. Another one is materialized views. This is a huge feature in Tinybird, where you basically do your computes and your aggregates as you collect the data and not at query time. And Postgres has a similar thing. I've been doing some reading where it doesn't sound like it's the best optimization step for real-time applications, although there has been cases. I think Timebase is an example where they've done a lot of work to make those materialized views more useful, more quick, so they are more appropriate for real-time applications. And also read and write replicas. If you're finding that your product is becoming very popular, hopefully that's the future for everyone in the audience. If you're building something like that, is to have read and write replicas. So as requests come in, you have a front end basically that's marshaling different requests to different instances of your database, basically divide and conquer. And that applies for both reading data in, but also writing data to the database as well. So these are different things to think about. The good news, and again with Postgres, is there's just tons of advice and information out there. If you are building with Postgres and noticing latencies that are affecting the performance of your app, then encourage you to obviously do some research and design your way, engineer your way to a more performant database. So one thing I want to show now, I'm going to switch gears and I'm going to bring up a different dashboard. This is under the hood. It's very similar. The only difference here is that this is, as I click around and pick different cities, as I switch my times, I'm doing requests both to Postgres, but also to Tinybird. And here, I'll show an example. So here, and then here's the important thing. Well, let me back up. So I'm really interacting with three different services here. One, I'm running Retool, and my Retool instance is on Amazon US West 2. I have a Postgres database that is also in AWS West. And then my Tinybird instance is running on AWS West as well. And originally, when I set this up, I had Tinybird, my workspace located over in Europe, and the latencies reflected that. So one of my first steps in this project was to move that workspace from actually Google Europe to AWS US West. And then I was actually working with a project that all these players were basically had parity in terms of where they're located. So as I make requests, you can see the different latencies here. This time series column is, you can see this running in the background. I'm moving data. It's a long story, but I wrote a script to move data from what I consider my production system in Google Europe. And I'm running that every minute to push data over to my new instance that's in AWS US. And this is the piece, okay, that's actually this piece. And I have a second script that's then running and taking data from my Tinybird instance in US West AWS and pushing it to Postgres. So that's what that's all about. So I'll not show that so it doesn't distract me.
I was trying so hard to find different cities as that was going through. I was seeing how many I could recognize there.
So it's been kind of fun. I have a lot of data being pushed around live in the background here.
Yeah.
But anyway, this first column is the latencies, how long these calls, and this is the latency round trip from Retool going to either Tinybird or Postgres and then back to Retool. They have a function in Retool called success handler. So anytime you make a request, regardless of where you're going, you can build in a success handler that, in my case, I'm just doing some simple timing, like tell me how long that call took and display it on the dashboard. It's a really useful feature. And they have a failure handler. So again, Retool has all these different features that you can blend in to your project.
Yeah.
So this first, oh, sorry, go ahead.
No, I was just going to say, this is only a week of data, and you can already see kind of the difference in latency and how Tinybird gives you that little bit of boost in performance. So I'm excited to see when we push it to the limit, what that difference is like.
Yeah, and that really was a fun part of this project. But this first column is what I call time series. That's the one that populates this table and most of these charts. It's just a simple fetch of like, bring me records from this city, from this starting point to this starting point, and that's it. As opposed to the daily aggregates. That's that query I showed with lots of averages, mins, and maxes going on. In theory, it's just a different type of query that I'm making. And another interesting thing here is, I'll highlight it here. Maybe I can zoom in a little bit. But in the payload, when I make a request to Tinybird, it gives me in the payload itself how long the database query took. And now that's the time that essentially the ClickHouse query took. And you can see, just 110 milliseconds for the query itself. The whole round trip in terms of rendering everything, preparing the query, sending it back, displaying it, takes half a second. But under the hood, this is the number that shows how long the ClickHouse, the Tinybird database query took. So let me show a couple other things. Before I showed how Postgres can struggle. If I do like a mini days, you can see how Tinybird comes back pretty quickly. The latency, here, I'll go back even further. There is a point where I can make the Postgres instance fall over. This will probably be one of those cases. No, it still survived. That's good. But one thing to point out is just the way that Tinybird can serve long histories of data. I can go back to February 1st. These graphs won't look very pretty because there's so much data. But the point here is that, let's see if Postgres survives this call. Now I am requesting a lot of data. This is nearly
timeout.
Timeout, yeah. So, I mean, you can force timeouts if you want. I've had a hard time forcing any timeouts with Tinybird, but let's go back to a more reasonable case. I want to look at just July, look at a full month. So here we're back. Things are running pretty well. I'm going to go back and just pull in a few days of data. And everything's pretty fast. I thought it was. Okay. And again, as I switch cities, let's go to Chattanooga.
Hi, Cameron.
So now the fun part. As part of this project, I wanted to, we talk a lot about performance on the query side of things, but there's another type of performance that all of us need to keep an eye on, and that is, what happens when you get a lot of requests for your data? You build up a website that's being driven by Postgres, and now, you have maybe 5 concurrent connections coming in, things are looking good. But as you grow, what happens when you have 100 requests coming in at a time? Like how do you handle that? And to do that, I wrote a third script that I called it stress case, where you can set how many threads you want to send with different requests in them. And these requests are randomized. And I did that because I didn't want a lot of caching to be going on, especially on the database side. I wanted each request to come in to pick a city at random and to pick a time period up to 90 days at random. So if I run this, don't know if you don't really need to see this, but I'm just running this script with threads equals 10. And let's see what happens. So it's starting to kick off different requests. Now I can come back to our UI and you can see what happens here now. Looking pretty good. Now let's change, let's increase our time frame. And you can see already quite a difference. I'm gonna up my amount of scripts, or I'm gonna increase this to, if I can see my own screen, let's do 30 threads. And again, I'll switch cities. And here with 30 different requests coming in, you can see that Postgres already, with at least the instance I have, is struggling.
Yeah, and this is still only a week of data, right? Like, so you
yeah,
can
let me go down
imagine
just a
kind of
few
request
days.
more.
Yeah, exactly.
Yeah.
So with my instance of Postgres, and I'm on the pro level of Supabase. There's different levels. You can do pro, and then quickly go up to like custom enterprise type support. So this is with the pro version. And I think with 30 requests, I think I'm already pushing the boundaries a little bit too much. On the other hand, you can see Tinybird so far has not been phased by these different requests. I'm gonna, just for fun, I'm gonna go back down to, let's find some middle ground, see what 20 looks like. Yeah.
Come on, come on.
Tinybird side looks pretty good. All right, let's kill the script. Let's get back to and just yeah. Now, so that's one lesson I learned, is that at Tinybird we talk a lot about the requirement to support hundreds or thousands of concurrent requests. We do have customers. We have customers. We have one in the retail space where during a Black Friday event or any other kind of sale environment where they are hosting 10,000 requests per minute or thousands per second even. And one reason they landed on Tinybird is for that feature where we can handle that. That we can serve that many requests. So if you find yourself in a position where you have a feeling you're going to be having to serve more and more incoming requests, just know that with Tinybird, you can do that. You can serve those requests, and you could probably do it with Postgres as well. It's just, again, how much money, how much time, how much engineering. If you don't have the engineering and the time, really, how much money do you have to throw at the problem to get a performant instance? And
then it's also too, Jim, right? Like the fact that it's not always Black Friday, right? Like you have dynamic amounts of requests, right? So we only want to pay for when we're actually like having all of those requests, and not just be paying for this hardware that's going unused most of the time, right?
Right. So again, I'm going to switch gears. Now I'm going to show different ways to pull Postgres data into Tinybird. So the scenario here is probably the most common case is like, you have large dimensional tables that you store in Postgres. Could be customer information, could be product information. In my case, I have this table, the location metadata. The events coming in, they give me one piece of metadata. They give me the site name, but maybe I want to map things. Maybe I want to do a join where I want to pull in all the reports for a state, bring in all the cities that are in that state. That's why I would need this extra metadata. Mm-hmm. So let's go into Tinybird, and I'm going to show you a relatively new feature. It's a table function to bring in data from Postgres instances.
Yeah. And if you want to play along at home, you have your own data, head on over to tbrd.co/try and, get started in just a few seconds with a free account. It's a lot of fun. I remember the first time I used Tinybird. It was fun, and I hope you'll create an endpoint at some time so we can see what happens when you press that button.
Yeah, sounds good. Here, I'm going to change this name to Get Locations. I'm doing that because I have a Postman example of where I can pull data once I have. Oh, I didn't hit return. So let's call this location. Get Locations. What's going on here? Oh, you know what? I already have this here. So let me get rid of that. What it had a namespace collision. I don't need this endpoint. Actually, I do want that one for later. Let me do my original thought.
Get Locations 2.
I'll just call it Postgres Locations because I love naming pipes that remind me like months later why I wrote this thing. Yeah. And this one will tell me, okay,
you already have one, Jim, the one you just had open.
Thank you.
Look, it's really hard to do live demos, so you're doing a great job so far.
I'm gonna do some cleanup on the fly here.
Yeah.
All right, I have this Postgres Locations. Thank you. And yeah, that is the magic of having more than one person on one of these live streams. So I have this pipe. I just created a pipe. And what pipes are? They're a set of nodes that contain SQL. In this case, I just need one node. I'm going to do some copy and pasting here because I'll walk through what I'm putting in here. But this is, here, let me copy this in. Okay, so this is this feature I was talking about. This is using our Postgres table function. I'm doing a select all. And then this is the special sauce here. I'm calling this function called Postgres-SQL. I'm giving it the host address of where my database is hosted. I'm going to the Postgres database. The table I want to bring in is called location metadata. As you remember, that'll match the table I have in my instance there. And I'm also passing in the username and password. This is using a variables API that we recently launched, where you can using the API, you can set up secrets and keys. I've done that already. So I'm passing in my Postgres username, my Postgres database password. If I run this, well, look at that. This is the table that you will remember was here. So just in one call, I've brought in that data. Now I'm going to build what we call a copy pipe. I'm going to create a copy. I'm going to base it on this node. I only have one, but again, you can have many nodes in a pipe. I'm going to do this one on demand. You can set these up as a schedule. I'm going to do a full replace. I don't have anything there yet, but I want to bring this in. Actually, yeah, I'm going to do this on demand. This is showing me what Tinybird sees as the schema. In general, this is auto inferred. You can see important things here, like it knows that these are float 64s. That's very important if you're working with lat longs. It knows that these are ints, etc. I'm going to create a new data source, and I'm going to call it site locations. And I'm going to run this one on demand. It's going to go off and do some quick work. It's a small table, so it was created quite quickly. And then another thing I can do is I can set this up on a schedule because I know maybe weather stations are retired or new cities are added to my system, what have you. So I can go in here and I can edit the schedule. I'm going to change it to a cron expression. This might be overkill, but I'm going to have this thing run every 10 minutes. I don't think my metadata will change that often, but you never know. I'm going to schedule this copy. So at this point, what I have here is I have a system in Tinybird that every 10 minutes is going to run out, do a call against this Postgres table, and pull in that metadata. In this case, it's going to replace it. I'll just get a fresh snapshot every 10 minutes. And then if I go, here's my new data source. There you can see, actually, I don't have 175 cities. I have 174.
Ooh. Jim, before we go on, I wondered if maybe you could just talk a little bit about, why do we want this as a data source, and maybe show that modal we get when we try to create a new data source from here versus doing a copy pipe, so you can see all of the
Yeah,
different connectors and different options you have to make a data source.
yeah, that's a great idea. So with pipes and data sources in the UI, you go up to this plus button, and I want to do a data source in this case. Yeah, and this is a menu of the different options you have for creating new data sources. And data sources, you can think of them as database tables essentially. But here are our native connectors. We have a native connector, for example, for Kafka streams and Confluent streams and Red Panda streams. And that's amazing. I don't know if you've ever tried to write your own code to consume these streams, but having this all managed by these connectors is a godsend. We also have methods for pulling in data really quickly. Say you're day one on Tinybird and you have maybe it's up at GitHub or something. You have some CSV or a JSON file you want to pull in. You can use a remote URL. You can also maybe have a local file. Maybe you had a database and you exported a CSV. Well, you can come in here and drag and drop those files. Let me continue my tour there. You can design your own schema with an editor using this. And then, of course, we have some of the big players for data warehouses: Snowflake, BigQuery, Amazon S3. And I talked about this one, the Events API. This, again, is a very performant posting endpoint where you can essentially stream in data. I'm using that in fact, behind the scenes here, moving data. I have, again, one script pulls from an endpoint on my Tinybird workspace in Europe. I'm turning around and streaming that data using the Events API into my instance in the US. So, cool. Yeah, a lot of good stuff there.
Yeah. And then once you have those set up, then it's basically like, you're using Tinybird as your database, and these are all just tables that you can, make joins between them and do all sorts of fun stuff and easily publish them out as APIs.
Yeah, exactly. So let's talk next. So there, I brought a dimensional table in, but now maybe I want to bring in more of a live data source from my Postgres. Namely, I want to work with bringing in reports that are showing up here. And again, reports here are showing up every few minutes. So to do that in Tinybird, well, you have many options. What I'm going to show you today is, again, using this copy pipe mechanism with a few changes. But know that there's other options. If you want more of a true live feed, I will say, it's right here. If working in the database world, you're probably very familiar with change data capture, CDC. And if you do want to go down that road, basically what it implies is that you're going to use some implementation of the Dezemian technology, which is something that will, on the database side, it hooks into the write ahead log. That every time a database change is made, this log gets populated with either inserts, updates, deletes, what have you. You have this component, the CDC component monitoring that log, and then it streams it. You can most commonly put onto a Kafka stream. And then using on the Tinybird side, you can use a Kafka consumer to pull that data into a table. I'm not going to show that today. It's quite involved, but if data freshness is top of mind for you, that probably is the way to go. It's a little bit more involved. The nice thing is, like many of these things, you may struggle to set it up once, but once it's running, you're good to go. But as an alternative, I'm going to show, this is a case where, my source data, in fact, is only getting updated every few minutes. So I don't really need up to the second feed. And I'm going to use copy pipes to implement a feed that may not be as fresh, but certainly is easy to set up. So I'm going to start a new pipe. I'm going to call this let's call it Postgres updates. And again, I have some magic code that I've already written because I'll fat finger.
I thought you just typed that fast, Jim, last time. I just didn't even notice.
Yeah.
Copy and paste is the live demo's best friend.
Yes. So let me set up a node here. This is going to look very familiar. In fact, all the connection details are going to be the same, except for, of course, the table I'm hitting. One thing I'm doing here, as I'm bringing data in, I do a now statement as last imported. And that's because when I do the copy pipe, I want to do incremental appends. And I want to know what data I should bring in based upon this timestamp that's tied to the last time I brought data in. So this will be the same from Postgres. The main difference here is I'm not going to that dimensional table. I'm going to my live weather reports table, same username and password. And then I'm bringing in data that was created after my last import. So again, I'll set this up to run every 10 minutes. But in this case, it'll just do an append of any fresh data and push it into this table called weather data from Postgres, which I'll show you that one in a minute. Actually, I can show it right here. It's a cool feature in our UI. If you click on a data source, it brings you the display of that. And what's useful for that is that you can click here on the schema tab and you can see all the different attributes. Often when you're writing queries, that's going to be an awesome thing to have, so you can, review your schema and, as you build your queries, know what the attributes, how they're spelled, etc.
Yeah. When I first discovered that was very helpful, because up till that point, I had just been doing select star from Blang, run it, and then referencing what's the results to then write the query. So that is definitely a lot more helpful.
Yeah. So I'm going to run this just to make sure I don't have any typos. It is bringing in a lot of data. Okay, but I last ran this. I last put fresh data in this this weather data from Postgres table last night. So anyway, there it ran. I want to do this as a copy pipe again. And I'm going to do on demand, at least the first time. I am going to select append. I don't want to replace everything, because remember, I'm just bringing in a little chunk of data that's recently arrived. It's going to, again, show me the auto-inferred schema that it sees. Key things I always look at is timestamps. I don't want them recognized as a string. If you can work with strings as a timestamp later in Tinybird, but it's nice to have it right off the bat in the data type that you prefer. This all looks good. I'm going to copy it to an existing table and hit next. It's doing some work to import all that data. It's analyzing the data it's pulling in, and I want to run that on demand right now. And I will say, I have another pipe. I didn't show it, but it's called backfill. I used this yesterday to backfill this table with about 6 weeks of data. It's a lot of data, and it's pulling it from Postgres. I found that if I tried to pull too much data in one request, it would time out on the Postgres side. So anyway, I built this. I'll show you this one too. It's really just the same. But if you go to this table now, we will have fresh data there. I have a playground, which we haven't even talked about, but I can see how much data is in this. I now have 1.5 million. So I still would have to do more backfill to get the full history in there, but I'll leave that for another time. And you can see here, I have pretty fresh data from just a few minutes ago. So yeah, that is a way. And then important detail here is to go back to that updates table. And I just did one on demand, but of course I want to set this up on a schedule. So in the background, it will just happily run 24/7 and bring fresh data into my Tinybird instance. Okay, so that's all set up now. So I can just walk away knowing that every 10 minutes I'm bringing in fresh dimensional tables from Postgres. But maybe more importantly, every 10 minutes I'm bringing in fresh data from a live feed.
Yeah.
And as someone who's been very focused on real-time data, I come from a weather background. That just makes me happy.
Yeah.
So that is a quick tour of this new feature. table function. We already support Postgres, and I can imagine other types of databases like MySQL and others will be on the quick roadmap.
Yeah.
And
yeah, now that Jim has given a nice tour, just a reminder that, it's quick and easy to go try out Tinybird for yourself, pull your own data in, play around. It's fun. Also, you didn't press a create API endpoint button, so we didn't get to see the confetti.
I can do that. I can go back to the one I almost deleted. Here's like a get locations example where I'm pulling all the data from my site locations, and I'm going to actually, it's already been published, so I'm going to unpublish it just so you can see the confetti and see how easy it is to create one of these things. I'm going to unpublish it. Now I'm going to go back and create an endpoint. Again, you get many different nodes. A lot of production pipes will have one node, and one node can build on the results of the node before it, so you can chain these things together.
Yeah, and that's super helpful too, just to do it in that kind of stepwise way. And also because at each point, you can give it a name that's helpful. You can add comments. You can, then pull from different nodes as you're doing subsequent queries and everything. And I for me, it's very helpful to kind of lay it out in that order. But exactly. Let's press the button. Let's
push the button. Boom! And now I have this endpoint. And I can improve that. I can go to here. I have Postman instance, and hopefully my credentials or everything haven't changed. Here you can see. Here, let me zoom in a little bit. You can see the URL I'm hitting. I'm going to our instance on AWS West, and I'm hitting this endpoint that I called get locations. I can send the data, and sure enough, let me shrink back down. And sure enough, here I have an endpoint serving me all these different cities and their geo metadata. So again, if you're building a dashboard, you can just call this endpoint and pull that data in. And you can do the same thing with the live data as well.
Yeah, if you can go back to Tinybird just for one more second, Jim. If you scroll down, one thing I love that's very helpful is these kind of templates to give you in different, kind of languages or different formats, like, oh, here's how you do it, right? So if you just like clicked through some of them there, you can just easily copy. And at least for me, instead of going all the way into Postman, I do love Postman, but being able to just copy that HTTP request from right there and put it in a browser tab to just check, exactly what I want, that is also helpful.
Yeah, exactly.
All right, we got 7 minutes. We got
I just want to show a few things. If you're interested in learning more about the Postgres table function, we do have a blog post. Our colleague Cameron put this out just recently. It's awesome. There's also a screencast about it. And of course, we have just pure documentation on it. If you go to the guides, our ingest location, we divide our documentation into starting off with concepts, but then how do you bring in data? How do you query data? How do you publish data? But if you go to ingest, and then our latest feature is this Postgres table function. So highly recommend, if you're interested, reading more about that. Okay, what else? And then for next steps, again, you can sign up and import your Postgres data all for free. We do have some more live sessions coming up soon. Our next one is with Cameron. It's on the 27th, talking about real-time personalization. And that, of course, is a key feature of more and more websites where you can personalize your journey, and we'll show you techniques on how to do that. And then later in September, we have more coming. I'm doing one on materialized views, for example, and how they're implemented in Tinybird and all the different types of database engines you can get into and what use cases are appropriate. So stay tuned for that.
And I need to plan my next one. So if anyone at home has any ideas or things that you want to see, shoot them in the chat, write it in the YouTube comments, let us know on our Slack community, which you can head on over here and join as well. Yeah.
So thank you, everyone, for joining us. We do have a few more minutes. If you have questions, just let us know. If you have questions about getting Postgres data in, you can feel free to email me at jim@tinybird.co. I'm happy to help.
Yeah.
And
you can email me and I'll forward it to Jim.
sounds fair.
Yeah. No, Jim, this has been great, and also I love the weather data example. A great way to get a lot of different data points there, and working with Retool. One thing, you mentioned you are more of a kind of back end guy, and me coming in, I'm kind of more interested in this kind of front end or full stack development. So we've been chatting about doing a project together to show how both sides can use Tinybird to harmoniously collaborate. So if anyone's interested in that, let us know as well. But Retool is also great, like Jim said, for getting these rich dashboards up and going. Maybe last couple seconds for any comments to come in. But Jim, any last words here?
No, other than I encourage all of you out there who are working with Postgres and you're curious about Tinybird, we now have this really simple way to pull data in. And then I would trust that your experience will be a lot like mine when I first started with Tinybird. In the first 2 hours, I had pulled in several different data sources. I had mashed them up using SQL, and I pushed a button and I was hosting an API, which kind of blew me away because in my previous world, I did a lot of work supporting APIs and just knew in-house how difficult they are to scale, to support, to document. And a lot of this is just abstracted away for Tinybird users, and it's extremely performant. So anyway, again, an easy platform to advocate for.
Yeah. All right. I'm going to do one last banner since I've been having so much fun with it.
Yeah.
I heart APIs. All right. I think we're good. I don't see any comments. Everyone who did kind of post a comment throughout, thank you for humoring us here. And tune in next week to hear from Cameron.
All right. Thanks, everyone.
Bye.
Have a good Tuesday.
Yep.
Bye-bye.